Okay, welcome 5th graders to another awesome video test review here. Today we're going to be talking about gravity and orbit. So hopefully you're at home, you're nestling, you got some hot cocoa, kind of depending on what the weather's going to be like, and you're ready to study. Okay, here's some of the things that you're going to need to be focusing on. One is the difference between mass versus weight. Okay, mass is how much stuff is on the inside. Okay, and we talked about this before. Whereas in weight is how hard you're being pulled down. So kind of depending on how hard gravity is pulling down on you, that's going to determine your weight. Okay? Whereas in mass is how much stuff you have on the inside. Okay? The way we kind of showed that is, let's say these two squares and these two circles were the exact same size. Okay? The circles are taking up the same amount of space inside the square, but you can see this one is actually a full, solid, dense square. So this one's going to have more mass, even though it's taking up the same amount of space as this other circle. Okay? So once again, mass is the stuff on the inside. Weight is just how hard gravity is pulling down on you. Okay? Let's look here. We talked about orbits. Orbit is just the path one object takes around another. An orbit can be a circle. Something can orbit something else in the path of a square. So how does it orbit? It orbits in a square. Okay? So orbit is just the path. Well, what kind of path? Ellipse answers that question. An ellipse is the shape. It's what kind of path or orbit the object is taking. And an ellipse usually is kind of like the shape of an egg. Okay, so you need to know that planets orbit other planets in the shapes of ellipses. Okay. Let's talk about gravity versus inertia. Why do planets continue to circle around other planets? There's two forces fighting against one another. Looking at your notes here, you have inertia that wants to keep going straight. Remember, we talked about inertia, and we had to really use our imagination here. If I were to push a ball ever so slightly, barely touch that ball, if there was nothing to stop that ball from moving, no friction, no wind was slowing it down, the ground wasn't slowing it down, the rubbery surface of the ball wasn't slowing it down. If there was nothing to stop that ball, it would just keep going on forever. Okay? So, a planet, wants to just keep going straight forever. If there was nothing pulling on it, it would just keep going on straight. But there is something that's pulling on it. It's called gravity. Gravity is just the force that two objects and how they're attracted to one another. Okay? So the moon is attracted to the earth. That's called gravity. So the moon wants to get pulled towards the earth because it's attracted to it by gravity. But inertia is like, no, keep going straight. So they're fighting against one another. So gravity pulls it towards it, but inertia fights it. Pull, fight, and the constant pulling and fighting against one another keeps the planet going in an ellipse around it. Alright, so once again, why does the planet continue to stay in an elliptical orbit around another planet? That's because of the constant battle and fight between inertia and gravity fighting against one another. It keeps the planet going in an ellipse. Okay? Also, you need to know, because gravity is the measure of attraction between two things, the closer you get to that thing, the harder it's going to pull you in. We talked about in class, if you've ever been to the mall and you drop in one of those coins, and the coin slowly goes around, but as the coin gets closer to the middle, it starts speeding up. That's the same thing with gravity. Let's say this is the sun, and this is Earth in January. Okay, we're exaggerating, obviously. You can see Earth, it's barely on that down slope. So it's not going to be falling very fast. because it's just right on the edge of the hill. But let's say Earth in May now, so in 5 months, once again totally exaggerating, that the Earth doesn't move that fast. But let's say now the Earth is gone here. The Earth is going to be pulling towards the sun a lot faster, because look how farther down it is on the slope, right? So the same thing. The closer you get to an object, the faster it's going to get pulled in. The stronger the attraction is going to be the closer you get to the object. The reason we don't feel the attraction between two things, like why aren't I all of a sudden getting pulled towards the video camera right now, is because the video camera is too small to pull me in. If it was massive, like the sun, I would get pulled into it. Okay, so the reason we don't feel gravity, the attraction between two things, like when we're walking on campus and all of a sudden I get pulled towards a friend, that's because they're too small. All right, so kind of keep that in mind. And lastly, how do tides happen? Waves, okay? There's a couple factors. One is wind causes waves. Another is the moon's attraction to the earth, okay? You can think of it kind of like a blanket. If you were to pull up on your bedspread, okay? Let's pretend like your bed is made, so it's draped over the bed, nice and clean. If you were to pull up on your bedspread, it would kind of make this tent. And then if you were to let it go, it would make little waves all the way up to the end. That's the same thing that's going on here with the moon. The moon is pulling up on the ocean, obviously very slightly. We can't see, oh, what's that lump doing out there in the middle of the ocean? Weird, right? It's real small, it's real subtle. But the moon is pulling up on the ocean, just like your bedspread. And then as the moon moves, okay, it drops. So it's kind of like picking it up, and then it's kind of like moving, right? And so your bed is going to flap over here. It's moving. It's going to keep flapping. So in the same thing, the pulling and then letting go, pulling and letting go, pulling and letting go, all the way around the earth is going to create these waves in the ocean. Okay, I believe that's about it. Yes. So hopefully you've enjoyed the gravity and orbit video science test review. If you have any questions, we got Edmodo, Facebook. Feel free to contact a friend, or you can text me looking at my classroom website where it says contact Mr. P. Hope you've enjoyed this lesson.